Okay, guys, this week we've been talking about tides, and so we're going to do a little bit in your journal. We're going to take some notes. You have two glue ins that you need to take care of. The first one is the causes of tides, so like to glue it in your next available page. Today is the 21st, so make sure you put the date on there. Page numbers for me were on page 98, so you can add that to there as well. And the second glue in that you're going to glue in is going to be the one that looks like a graph. It looks just like this. You're going to glue it on the next available page. Go ahead and put the date as well for that. So it's the 21st. And it would be, actually we're odd numbers, so it wouldn't be 90, it would be 99. So this would be 101. And the title for these notes is going to be Tides, right here. And we're going to start off with a video. So I'm going to pause real quick and let you have time, take your time, get your gluing in that you need to glue. When you're ready, then go ahead and restart the video and we'll start with that. Okay, hopefully you've had time to glue in your two glue ins. If you haven't, pause the video, take care of that now. And we're going to watch this short video just to kind of refresh your memory on what we've already talked about in regards to the tides.
Welcome to Math and Science. In this video, I'd like to talk about what causes tides. Tides are the rise and fall of sea levels caused by three items: gravitational force of the moon, the sun, and the rotation of the earth. Gravity is the force that pulls everything in the universe towards everything else. Even though the moon is much smaller than the sun, the moon's pull has a much more pronounced effect on the Earth's ocean because it is closer than the sun. The moon exerts around 2.5 times more force than the sun. On the side of the Earth that's facing the moon, the pull of gravity causes oceans to bulge outward. On the other side of the Earth, the moon's pull on the solid ground causes the oceans to bulge there. The Earth rotates on its axis, so this bulge is constantly changing location. The moon thus tends to stretch the Earth slightly along the line connecting the Earth and the moon. The solid Earth deforms a bit, but the ocean water, being fluid, is free to move much more in response to the tidal force. Where the bulge is bigger, it's high tide. Where the water doesn't bulge, it's low tide. In this picture, you can see the difference between high and low tide. The moon's orbit around the Earth also causes tidal changes. Most places get 2 high tides and 2 low tides each day. Approximately twice a month, around new moon and full moon, when the sun, moon, and Earth form a line, the tidal force due to this alignment is at its maximum, and the tide's range is also at its maximum. This is called spring tide. When the moon is at first quarter or third quarter, the sun and moon are separated by 90 degrees, and the solar tidal force cancels the moon's tidal force. At these points in the lunar cycle, the tide's range is at its minimum. This is called neap tides. So there we go, a bit of information about tides and why we have them. Thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share.
All right, guys, so we should know at least that we do have 2 high tides and 2 low tides every single day. However, sometimes we do have moons that give us special tides. So those are our quarter moons, so our new moon, first quarter, full moon, last quarter. When it comes to those particular tides, they give us some special tides, and we have some special names for them. So let's first start with the new moon. The new moon, again, is always going to be between your sun and your earth. So here's our new moon. It'd be completely dark right here. So when it is in a nice straight line like that, we've got the moon pulling on the earth like that. And let's say here's our sun. Our sun's over here, our sun is yellow, and our sun is also pulling in the same direction over here. So we've got really large high tides. So these are higher high tides. Okay, so we've got a high tide here and a high tide here. Okay, super high tides. That also, I mean, we don't have extra water on Earth, so this means that where does the rest of the water, if all the water is over here, then over here during our low tide, here and here, these are our low tides, and these are super low, lower than normal, low tides. So because all the water is over here over off to the sides on our high tides. So these are low tides. Excuse that. So again, when we are on a spring tide, that's either a new moon. That also goes with the full moon down here. So same thing, when you are in a nice straight line right here with the earth, moon, earth, and sun, or in this case, earth, moon, and sun, you've got higher than normal high tides. So higher high tides, because you've got both the gravity of the moon and the gravity of the sun kind of working together. Higher highs and lower lows. Over here, your low tides. Lower low tides. Okay. All right, so then that leaves us with the quarter moons. The quarter moons, they create right angles. So you've got our moon pulling up in this direction and then our sun pulling over here in this direction. Now, remember that our moon does most of the, has most of the effect on the ocean, on our water. Our sun is a lot bigger, but it's much further away. So, but it does have an effect on it as well. So here, now these are pulling in opposite directions. So we do still have a high tide here. This is still my high tide. This is still a high tide. And this is still a high tide. But if you notice, just looking at the water here, these are not as high as they normally are. So these are lower than normal high tides. These are my lowest high tides, I guess. And again, because we've got the sun kind of counteracting that little area right there. And then over here, the sun is pulling in this direction over here. And so it's pulling on some water here. So these are my low tides. And so these are higher than normal low tides. So we've got higher lows here and lower than normal high tides over here. This is going to be the same thing happening here because we've got the moon pulling in this direction, the sun pulling in this direction. The high tides are always going to follow my moon. So my high tides are over here. My low tides are going to be opposite that. So my low tides are over here. And so these are lower than normal high tides. And these are because some of the water is being pulled over here by the sun. And these are higher than normal low tides because the sun is helping to bring some water on the low side as well. All right, so I'm going to stop right there. All right, guys, so again, these are my spring tides. Our spring tides are our super strong tides. I say spring or strong tides. This is my new moon. Okay. So spring tides here. And again, this is also a spring tide over here. And again, these are my strong tides. This is my full moon over here. Okay, and then my neap tides are these over here. This is a neap tide. and this is going to be my quarter moon. My neap tides are my week tides. Neap and week kind of sound a little bit the same. This is my first quarter. So these occur on my quarter moons when the moon and the sun and the earth are in right angles, or right angles, 90 degrees from each other. So these are my week tides, and this is again my third quarter. So again, when they're in a nice straight line, they've got our spring tides. Think like a spring, like one of these springs, and they jump off of the earth really high tides, which doesn't leave a lot of water again, so very low tides on the low side. And then over here, these kind of, if you look at the water, these are kind of pretty nice and evenly spaced out. So these are lower than normal high tides and higher than normal low tides.
Okay, guys, so we just took some notes on the high and low tides, and we're talking about spring and neap tides. So this is kind of a really neat side-by-side comparison of spring and neap tides on a coast in the UK. So we're going to play this. There's no audio, so I'm going to be talking you guys through it. So here you can see this looks like a pier of some sort. There's some boats. So the tide, obviously the high tide is coming in on both. However, on the spring side, you'll notice the high tide is much higher. It goes a lot higher, significantly higher. The neap tide is in high tide as well over here on the right, only it's not as extreme. Now we're going to go into low tide. Both of them are going out again. They're both going into low tide, but on the spring side, you'll notice the low tide is much lower than the neap side. Okay, guys, so that was a really quick video, so I just want to come back to it. Again, this is paused. High tide during spring tide is much higher over here on the left side. Look at how much higher on this pier or dock, whatever that is, that the water is. It's high tide on both sides. Remember that, only the spring tide is much higher. Now, when we come over here to the low tides, you'll notice, again, the neap side is lower than it was before, but it's not nearly as low as the spring tide. So that's when we were trying to emphasize that the spring tides are these super high and super low tides. They're very extreme tides. Neap tides still have highs and lows. They're just not as extreme. The highs don't get quite as high, and then of course the lows don't get quite as low. Okay, guys, we're about to continue talking about spring and neap tides and show you a really neat animation, do some more notes, but we're going to have to cut part one short due to time. And so you'll pause the video, you'll close it out, and you're going to open the second video. It's going to be labeled Tides Part 2, and continue on with your lesson.